Welcome to this session. This session we derive the reduction formula for sine power nx for n greater than or equals to 2 and see how to apply it to a specific integral sine power 4 x dx. So let's proceed. Now this is the integral that we have. You see a power n can be written as a power n minus 1, a power 1, or just a. So we'll split this integral as sine power n minus 1 x and then times sine x dx. And then let u to be sine power n minus 1 x and let dv be sine x dx. Now you see du using chain rule will have n minus 1 and then sine n minus 2 x times cos of x dx, and v, the integral of this will be negative negative cosine of x. You know that the integral of sine is a negative cos function. So we know that integration by parts formula is integral of u dv is uv minus integral of v du. So integral of sine power n x dx will be the integral of u is this function, this v. So we'll have uv will be given by minus, so this equals to minus cos x times sine raised power n minus 1 x, and then minus v du, so this will be plus n minus 1 integral of sine power n minus 2 x cosine of x and then times cosine of x dx, which will give us integral of sine power n of x dx is negative cos x sine of n minus 1 x plus n minus 1, and then integral cos is cos squared, so sine n minus 2 x cos squared x dx. But we know that cos squared x is 1 minus sine squared x. So using that one in this position, we'll have integral sine power n x dx is negative cos x sine power n minus 1 x plus n minus 1 integral of sine power n minus 2 x 1 minus sine squared x, and then dx. I've replaced by cos squared by 1 minus sine squared. Now if I let this to be I, then I'll have minus cos x sine power n minus 1 x plus n minus 1 integral of, now this will be sine power n minus 2x dx. This by this, so I'll have minus n minus 1, n minus 2 plus 2, loss of interest gives me n. So sine power n x dx. And you see by definition, I've said sine power n dx is I. So this part is also I. So this is just I. So this means that we have I is equals to negative cos x sine power n minus 1x plus n minus 1 integral of sine power n minus 2x dx minus n minus 1 times I. So collect those terms in i's. So bring this to the left, you'll have I plus n minus 1 I equals to negative cos x sine power n minus 1x plus n minus 1 integral of sine power n minus 2x dx. Now coefficient of this is 1, so 1 plus n minus 1 and then multiplied by I is negative cos x sine raised power n minus 1 x plus n minus 1 integral of sine n minus 2 x dx. So which tells me that 1 plus n minus 1 is n. So ni is negative cos x sine of n minus 1 x plus n minus 1 integral sine power n minus 2 x dx. So which tells me to get I alone, I divide through by n, so minus cos x sine n minus 1 x divided by n plus n minus 1 over n integral of sine n minus 2 x dx. So therefore, the reduction formula for sine raised power n reduction formula for sine integral of sine power n x dx is integral sine power n x dx is negative cos x sine power n minus 1 x divided by n plus n minus 1 over n integral of sine power n minus 2 x dx. So that is the formula. That is the solution to the first part. And finally, we finish to get the value of the integral of sine power 4 x using this reduction formula. So this is the answer to the first part. Now, integral of sine power 4x dx, n is 4. So we have integral sine power 4x dx will be negative cos x sine of 4 minus 1 x divided by 4 plus 4 minus 1 over 4 integral sine 4 minus 2 x dx. So simplifying, we'll have negative cos x sine power 3x over 4 plus 3 over 4 integral sine 4 minus 2 is 2 dx. Let's call this one equation 1. Now we also are required to find the value of sine squared. So integral of sine squared x dx. Here n is 2, so it'll be negative cos x sine of 2 minus 1x divided by 2 plus 2 minus 1 over 2 integral of sine 2 minus 2 of x dx, and 2 minus 2 is 0. Sine of x raised power 0 means sine x raised power 0, which is 1. So we'll have negative cos x sine x over 2 plus a half integral of 1 dx, which is just negative cos x sine x divided by 2 plus a half, and then half x plus a constant, call it C1. So call this one 2. So the answer will be simply to replace 2 in 1. So replacing 2 in 1, we get integral of sine of 4 dx is, so the first term is minus cos x sine power 4 sine power 3 x over 4 plus 3 over 4 into negative cos x sine x divided by 2 plus a half x plus C1. Let's simplify this. So integral of sine power 4x dx will be negative cos x sine cubed x over 4 minus 3 over 8 cos x sine x plus 3 over 8x, and then plus c, where c is 3 over 4 C1. So that should be the answer to that given second part of the problem. Thank you.